he is my colleague also. Now, before starting his presentation, I want to introduce him to our participants. Mr. Sourav Kumar Das obtained
Am I
his
audible, sir?
yes.
Okay, okay,
Mr.
okay.
Sourav Kumar Das obtained his MSc in Physics from Vidyasagar University, Midnapur in 2004. He is currently working on the applied optics and optoelectronics under the University of Calcutta, and he is now expert on different programming languages such as he has developed multiplexer based optical logic gates like NOT, OR, and XOR, NAND, NOR using electro-optic mechanism, gender interferometer supported by Python based simulation. He has published many research papers in different international journals, Scopus based and Web of Science based journals, Springer, Elsevier, like that. Professionally, he is assistant professor in physics, and he started his service life from Shri Gurudas College under the University of Calcutta during 2015 to 2020, and since 2020 he has joined in our college in the department of Raja Narendra Lal Khan, Department of Physics, Raja Narendra Lal Khan Women's College, and he has published different books on honors level under different national publishers in Calcutta, West Bengal. So I request our speaker, Mr. Sourav Das, who will deliver the lecture on numerical methods under the environment of Python. Now I request to start your lecture for our participants.
Thank you,
Saurabh,
sir.
Saurabh sir, please start your
Uh,
presentation.
okay, sir. Sir, my topic is basically uses of different libraries such as SciPy, SkinPy, etc. of different libraries of Python to optimized way. What is the editor? First, we have to learn the what is the editor of the I present you. What is the editor? We have different editors of Python, such as ideally Python, Jupyter Lab, step by step, and we know also Anaconda. Anaconda, this is the Jupyter Notebook under the Anaconda software. But this is very large software. We have another way to run the Python very easily. What is the we can use the Colab. Colab is the Google based Jupyter Python, and this is the Google product, and we can easily store the program in the Google Drive, connect to the cloud based runtime, and easy sharing. Sir, this is the Colab, and we can easily run the Python program in Colab. First, we have to go Sir, my screen is on visible. Sir, my screen is visible.
Yes, yes.
Sir, first we have to go Google Colab. Google Colab. Google Colab. This is the cloud based, and we can share our programs in any device with any person. And this is the Colab. First, we have to sign in or sign up the Colab or welcome the Colab. Sign in. After the sign in using our Gmail or Google account, we can enter the cloud-based Jupyter notebook. This is welcome to Colab and code. This is the code. In this code we can write anything, and after typing here, we can run in run cell, pressing the run cell, pressing the run cell. Suppose, sir, this is I have prepared the PDF and
Yes, your screen is visible.
still visible. We come from the basically mathematics background, and all are known about the numerical analysis. And I mainly focused about the Python libraries such as SciPy, and different computational techniques provide the uses of Python. First, we know that the basic this is the bisection method. Is the equation of bisection method, and we have to first focus about the roots of the Python, roots of the bisection. Suppose import numpy as np, and we import the numpy library as short name np, and from and import scipy also. Scipy, what is the full form of scipy? Scipy means scientific Python, and many ready-made programs includes the scipy library, and thereafter from scipy dot optimize import bisect. That means in scipy module there is bisection method. Thereafter define fx, that is we define the function return x star star 3 minus 2 star x minus 5. What is the function? Function is the x cube minus 2x minus 5. Thereafter, we define the function, and therefore a b are the roots, roots lie between 2 and 3, approximate roots. Root That is, we use the bisection method. Bisects F A B and X tolerance value 1 E minus 6. 10 to the here the tolerance is 10 to the power minus 6. After that, print root found is equal to then run. What is the value? 2.09955240. That's it. What is the step of this program? Bisection program. This is a ready-made program. If we prepare this program using C++ or in Fortran, we have to write many steps to prepare this. But using the SciPy, we can easily, in less steps, we have found the root. X cube minus 2x minus 5. What is import SciPy? First we import SciPy. Thereafter, in SciPy, optimize is another module, and import bisect within the SciPy all
Excuse me, sir.
numerical.
Hello.
Yes, sir.
Sir, in that code, root equal to bisect f comma a comma b x tol tol equal to what that visible actually not read.
हाँ, a comma b.
Yes, sir.
हाँ, a comma b. f is the function. A and b are the root light between C and B.
Okay, sir. Then x tol equal to write that you have written.
xp x tolerance
Okay, okay,
value of x value.
okay, okay. Thank you, sir.
This is the tolerance. Ma- Madam, I think that you are all are from the mathematical background.
Yes, sir.
You are
Yes,
well
yes,
aware the
yes. Okay,
bisection method.
Sourav, yes, yes. But madam want to know what is the meaning of X tolerance, and madam that have indicated to you.
Yes,
Okay,
sir.
Oh,
okay.
Thank you, sir.
x tolerance is the tolerance value. Tolerance value we can write the minus 7, 10 to the power minus 7, and run this.
Okay, thank you, sir.
It's
In
level of
another
acceptance. Tolerance means level of acceptance, that is error within the
huh,
range 10 to the power minus 7.
minus 7. Huh.
Okay, okay.
Thank you, sir. Thank you.
So with less step we can run this program. Another program using bisection method from the SymPy is also library like SciPy. From import SymPy from SymPy, import symbols, equation, and solve. X is equal to symbol x f is equal to, this is the program, x 3 minus 2x minus 5. Thereafter, root someone equal to n solve equation f 0 2, and thereafter print was found and true. Run this. It's a program. Import symbol. Symbol, symbol. Import symbol. So this is done. So program, our program is run. Here we have used the SymPy module, another module like SciPy. And in this way, in less step, using the bisection method, we can run this. But on a SciPy is well-known module than SymPy and well developed. Now, next is the second method. We all know about the second method in mathematics, and using the second method, how we can write the Python script to run the program. Import numpy as np. Next, import scipy. Next, from scipy, dot optimize. Import root scalar. This is the another function using this scipy module. Therefore, define the function again. Again, x cube minus x. Here x, here x minus 5 minus 2. Another function. Next, solve is the variable root scalar f method the second initial roots are x0 is equal to 1 and x1 is equal to 2. Our roots lie between 1 and 2. Next step is the if solve dot convert print thereafter print root found. Root found, and this is the solve dot root. And there are else print method did not convert. Method did not convert. Convert. In this program, program. In this program, first import numpy module, and in for we write the numpy as np. Then we import the scipy module, and scalar root scalar from scipy dot optimize will provide the second method. So every ready-made program is included in scipy module. Here root scalar from scipy dot optimize which provides the second method. Thereafter, in this step, we define the function x³ minus x minus 2. Apply the second method. The function root scalar is used with method second to specify the second method. In this step, we have specified the second method to the compiler. And initial gauges are x0 is equal to 1 and x1 is equal to 2. This function iteratively updates the values it founds the root, checking the convergence. After iteration, the program checks whether the solution has converged. If converged, the compiler prints the root value. Otherwise, it prints that the method did not converge. This is the very short, optimized way we can run a program to find the root using second method. But if we use C++ or Fortran, we have to write many steps to run this program. And next we go to the Newton's rapture method. We all know that the Newton's rapture method, this is the expression of Newton's rapture formula. Xn plus 1 is equal to xn minus fxn by f dash xn. Here algorithm is we first define fx f dash x and give the starting point a and tolerance value, and then calculate fx by f dash x and update x until mod of fx greater than tolerance. Next, in Google Polar, define fx return means we specify the function x³ minus 2x minus 5. This is the function, and another function is f dash x, but differentiation of the function with respect to x. definition hx, we denote it hx. Return cx. This is the x cube, the differentiation of x cube is, we know that 3x square. This is the 3x square, 3x square minus 2. This is the differentiation of upper function. And we specify the x and tolerance. Evaluate input initial point tolerance in. Okay. Thereafter, while the absolute value of fx greater than is equal to tolerance, then x is equal to x minus fx by hx, fx by hx. Print x. And print the root. Print the root of equal to x. And run this program. You have to write the initial point. Where initial point 3.0 and tolerance is 0.001. Enter. Root is 2.094551. Here we have used the function x cube minus 2x square minus 5, and we use the initial point 3.0 and tolerance is 0.001. Using the second method, in this way, second Newton's rational method, we can evaluate the root of the function. And another programming from SciPy. Import SciPy. Import SciPy from scientific Python. Next, from SciPy dot optimize import Newton. Next, define the function f is equal to lambda. Lambda means we have defined the function lambda x, function of x cube minus 2x minus 5, and then root is equal to Newton's rational method. Newton f x0 is equal to 3.0 initial value, and tolerance 10 to the power minus 3, 1 e minus 3. This is the tolerance value we have taken. And print root is equal to root is equal to root. We run this program. Input from 0 lambda lambda. In very short steps, using the Newton's reaction method, we can write this program. First, we import the scipy, and from scipy.optimize import Newton imports the import method function from scipy optimization module, and then define the function x3 minus 2x minus 5 is defined using a lambda expression in Python as f is equal to lambda means x, f is the function of x, and this is the form of the function. Built-in method is Newton. F x0 3.0 and tolerance is equal to 10 to the power minus 3. Apply the Newton's reaction algorithm to find the root of the fx is equal to 0, starting from the initial got 3.0, and here tolerance is 10 to the power minus 3. So the output is the root is equal to this. This is a very short method to deduce a find of a root using the Newton's reaction method, using scipy module of the Python. And next, we go to the integration. We know this Newton's numeric photo difference formula, phi x is equal to y0, delta y0, and this function. For n is equal to 0, we have the rectangular rule, n is equal to 0. And for n is equal to 1, we have the trapezoidal rule. And for n is equal to 2, we have the Simpson's one-third rule from equation 13. And for n is equal to 3, we have the Simpson's three-leg rule of integration. First, we have the trapezoidal rule. We have the trapezoidal, n is equal to 0, trapezoidal rule. The composite formula is, if we break the interval into many sub-intervals, we have this equation. I is equal to h by 2 y0 to y1 plus y2 up to yn minus 1 plus yn. And we have to deduce the integration 0 to 1 x square dx using the trapezoidal rule. Import numpy as np and xh is equal to np dot linspace 0 1 and step it 101. Step is equal to 2. Function, you write the function y is equal to x square and I is equal to 0.5 and half h star y0 plus y1 y minus 1 plus two star sum y1 minus 1 print integral is equal to I. Then run this code. This is the result. So here the steps of this program is we first import as NumPy. NumPy library which provides the numerical and mathematical tools for array operation. The previous speaker elaborately discussed the NumPy module. Then creating grid points, XH, we have create 101 equally spaced points between 0 and 1. Using the link space, we can create equal spaced number of points between 0 and 1. X stores the array of values and A stores the spacing between two consecutive points. That is the step size. Here X stores the array values and A stores the step size. Next step, we have defined x is equal to x square. And the next step, the trapezoidal rule, that is half h by 2. Here y0, the y in minus 1 means the last value. Y minus 1 means the just last value. And thereafter, hello.
Yes, sir, I'm following.
Sourav Babu, please continue. Hello.
Hello.
Hello, Sourav Babu, please continue. I think there is a networking problem most probably. So all are requested to stay here. Sourav Babu, yes. Hello, Sourav Babu.
Yes, sir.
Please continue.
Sir.
Okay. Any technical problem?
হ্যালো, হ্যালো।
Yes, you continue. Please, Sourav.
হ্যাঁ, ঠিক আছে, ঠিক আছে।
Okay.
And in this,
Saurabh, I think two devices are on a simultaneously, so there is a echo.
দাঁড়ান স্যার, শোনা যাচ্ছে নাকি দেখুন।
Okay, continue,
হ্যালো,
please. Continue.
হ্যালো, স্যার
Yes,
শোনা যাচ্ছে?
ah, continue.
কারেন্ট চলে গেছিল, এই জন্যই অবস্থা এরকম।
Okay, no problem.
হ্যালো,
Yes, please continue.
ওকে স্যার। In this step, this is the h by 2 fx0 fxn and 2. This is the integration. Summation means this is in this step. This step is this. স্যার শোনা যাচ্ছে আমার কথাগুলো?
Yes, we are audible. So please
ওকে স্যার,
continue.
ওকে। And next, print integral I. And very short method, we have run this program using Newton's Raphson, using this trapezoidal rule of integration. And another program is trapezoidal rule. Import numpy as np, then import scipy, and from scipy dot integrate import quad. Next, f is equal to lambda x square. Next, I is equal to quad function f 01. And next, print integral I. Next, print integral I. So this is another method of this program. Here we import the NumPy module, NumPy library from scipy.integrate import quad means import the function quad from scipy.integrate module, which is used for numerical integration. And we have defined the function fx is equal to x square, and the command I comma at the rate is equal to quad f01 means the quad function evaluate the integration of f from 0 to 1. Initial value is 0, final value is 1. This result is stored in I variable, while the second return the value and estimate of error is ignored by assigning it to at the rate. Displaying the result, print integral I, and here is the result 0.0000 last of all 37. Next, we go through the Simpson one-third rule of integration. This is the Simpson one-third rule. We also known for n is putting n is equal to 2 in Newton's Gregory formula. We have arrived this equation 19. I is equal to h by 3 y0 plus 4 y1 plus y2, and this is the composite formula of Simpson one-third rule. This is the if we break this into many components, then we arrive equation 22. This is the composite Simpson formula, and using NumPy we can easily solve this program from
Actually, this is Simpson one-third formula.
one third rule, sir.
Yeah.
Import NumPy as np. Next, xh is equal to np dot linspace. But we have generated equally spaced some grid points between 0 to 1, 101 number of equally spaced points. Rate step is equal to 2, and now y is equal to x square, and here I is equal to h by 3 star y0 plus y minus 1 plus 4 star sum y starting point, starting and ending point, and step is equal to 2. Start, stop, and step plus 2 plus 2 star sum y to starting ending মানে even number of y to y4 is the same, and print integral I. This is the, after running this program, we have arrived the same result, Simpson method. And using the SciPy module, the alternate program is import. This is the alternate program. Import numpy as np from SciPy dot integrate import Simpson Simpson x is equal to np dot linspace 01 01 101. This is the, we have generated equal spaced points, 101 number of points. Next function y is equal to x star star 2. Next I is equal to Simpson 1/3 Simpson yx, and next print integral I, print integral I. Run this program very easily, very least step. We can run this program using Simpson 1/3 rule of integration. From Simpson is SciPy. This is the Simpson variable, Simpson command. Simpson command is SciPy's implementation of composite Simpson's rule for numerical integration. And here the grid points x is equal to np linspace 0 to 1, 101 means this creates 101 equally spaced sample points between 0 and 1 interval. The uniform step is 1 minus 0 by 100, that is 0.01. And next we have defined the function y is equal to x square, and using the I is equal to Simpson yx means to composite Simpson 1/3 rule approach for this integration. So if we write the program using C++ or Fortran, we have to write the many steps to run this program. But using Python and basically SciPy module, we can run this program with optimized steps. Okay, sir.
Okay.
Next, Simpson 3/8 rule. Simpson 3-8 rule, sir. Next, we have the Simpson 3-8 rule. Simpson, we know that this is the composite function of Simpson's 3-8 formula. I is equal to 3h by 8, y0 plus 3, y1 plus y2, y4, y5, and y. That is the and plus 2 into y3 plus y6 plus yn. This is well-known formula of Simpson 3-8 formula, and the corresponding Python script. Very easily we can write import SymPy. Using the SymPy, we can write this program very easily. Import SymPy, another module of Python for numerical calculations at SP. এটাকে তো এই করা যাচ্ছে। You can run this program. X SPX symbols X integrate line 2. Oh, import SymPy at symbols X X. Sir, the very easiest way using the SymPy module to run this program. And now let us start the ordinary how we use the ordinary differential equation. Ordinary differential equation. And first of all is Euler method. We know that this Euler method, and this is the well-known formula, Euler's formula, yn plus 1 is equal to yn plus h f x and yn. And this is the program using the Euler's method. Import numpy as np, import matplotlib.pyplot as plt. This is the function lambda x is equal to y is equal to 2xy. Euler's method is compact form. Euler f x0 y0 f x0 y0 hn, and next x lin space. This is the x is equal to, we have created the equal space points np dot lin space x0 plus n star h n plus 1 And now y is equal to np0 is n plus 1. And next y0 is equal to y0 for I is equal to I in the range yi plus 1 is equal to yi and return xy. Return xy and xy is equal to Euler f minus 2 1 1.040 and y exact is equal to np dot exponential x square minus 4 and print np dot column stack x6 exact and plot plt. This is the in the steps. This is steps 20 error xy plt dot plot ro ro l b b means black. Run this program. So this is the, if we run this program, we have obtained this type of output. Here, the different step of this program is, first we import numpy as np and matplotlib.pyplot is the module. What is the name matplotlib? Matplotlib is come from the MATLAB. MATLAB come from this MATLAB matplotlib dot pyplot. Pyplot is submodule. This is named as PLT. And now define the ordinary differential equation dy dx is equal to 2xy. Next, Euler method is used to approximate the solution of the differential equation, and iterative formula is yn plus 1 is equal to yi plus h f xi yi. H is the step size, xi is the current value of x, yi is the current value of y. In Python, this is implemented by initializing the arrays and x and updating them in a loop. Step 4, initial condition is y minus 2 is equal to 1. That is the value of x0, y0. The initial condition is y2 as minus 2, this is equal to 1. And the step size h is equal to 0.01. And total number of steps is 40. Using this command, we have defined this method, and exact solution is yx is e to the power x square minus 4, and output of this program x is the grid point and program plot numerical solution using the, here the red circle with connected line indicates the numerical solution using Euler's method. Red circles with continuous line. Here we have used RO. RO here in a plot. RO means R means red. O means is a red circle. And label this as Euler method. This red circle which continuous line indicates the Euler method solution, and black and blue circles continuous cut. This is the exact solution. Blue is the exact solution and red is the solution using Euler's method. This is the output of this program, and the function is fx is equal to 2xy.
Sir,
Now,
So Babu, one query is there
yes,
uh,
sir.
from the Sivaranvi. Any query?
yes, sir.
Uh,
Could
uh,
you please explain what is the column stack code NP dot column stack?
Voice is very low. So again, please repeat.
Sir, could you please tell me what is NP dot column stack? Column stack. So to print only few values we are using that code, right, sir?
NP dot linspace.
NP dot column stack, sir.
In,
NP dot linspace. Oh, column stack. Oh, column stack
Yes,
means it's a column. NP dot print column stack. Man, this is the column stack. NP dot column stack x 6 x y মানে only 6 column are there. 1, 2, 3, 4, 5, 6. 6 column. মানে NumPy মানে NP column stack is also included in NumPy module. A sub module. This is the sub ready-made module.
okay, sir.
Column stack means there are the 6 column. Y and for each and x for each x 6, y 6 and y exact. This is the exact value. Last column indicates the first column indicates x value. Second column indicates the y value, and third column indicates the exact value.
Okay, sir.
And column stack is the a command, ready-made command in NumPy module.
Okay, sir. Okay, sir. Got it. Thank you.
And here the legend. This is the legend means we have write this as a level to level something within the card. We have used the legend command, a plt.legend. Another question.
no, you continue. Repeat.
Okay, okay, sir. And last of Rungakutta 4. Rungakutta 2, we know that the Rungakutta 2 and Rungakutta 4. Rungakutta 2. Now everything is in, explanation is includes in my PDF.
You
All steps.
you can
All-
share your PDF to our participants. Okay.
Okay, sir. Okay, sir. I'm sharing this.
Okay.
And this is the same mm, same integration using Rungekutta 2. And this is the we know these steps in Rungekutta 2, and this is the such program output, and this is the explanation of every steps, every command I have used. And Rungekutta 4, this is the equation, well-known equation of Rungekutta 4. And if we use this, just copy and paste. Colab is very user friendly editor of Python, sir. Jupyter Python. We need not store Anaconda like heavy software in our device. This is the cloud based and free to access. Welcome to Colab. 2xy matplotlib. import matplotlib as plt dxy 2xy differences and return initial the domain x0 y0 is equal to -2 1 and xm is equal to 2 solve is equal to solve I vp f x0 xf y0 method is rungi kutta 45 rk 45 rk 45 and then output is equal to true. Next, now run this program. OPLT. This is, sir,
Yes.
this is, we can save our image also in this collab. And every program is stored in our Google Drive. If we use the collapse editor, every program is already automatically stored in our Google Drive, and we can share it with our friends also. This whole link will be shared like overlay in Python. This is the Runge-Kutta process. RK4 solution is RK4, and here the differential equation. Just we have used import matplotlib SkyPy integrate import solve IVP means if we use the Runge-Kutta for method, we have import this command. And next, there are many things in numerical analysis. Next, we use the curve fitting. This is the points, and we want to fit this point with this y is equal to mx plus c. And this is the program of curve fitting. We have array, suppose black, black, data point, data point, data point. Yes, sir. This is another program of regression analysis. Sir, there are large subject inputs in the numerical analysis, sir. So this is the out of scope in my lecture, sir. In this PDF we have write many program RK2, RK4, etc. Sir. Using Odient library. This is the second order differential equation, and from SciPy dot integrate how we have solved this differential equation. This is the question: solve this differential equation and write Python script of the following. And this is the program, and this is the output, sir. Complete output, and this is the graph. Sir, all are included in this PDF, sir. Sir,
You
any question?
must, you must share your PDF to our participants in group.
Okay, okay, sir.
Okay. I think you have completed your presentation. Am I wrong? Or any more? Hello?
Yes, sir. Yes, sir. Yes, sir.
Have you completed your presentation?
Yes, sir. Yes, sir. Sir,
Okay.
actually, numerical analysis is the large subject.
I know it because
We didn't.
all participants are from mathematics, so
Huh.
they are concerned about the numerical analysis, and
Hmm.
we are already concerned that numerical analysis must be used where the exact solution are not given. Then we should apply the numerical methods.
Hmm.
So and there are so many methods in our textbook, but using the Python programming we can find out the solution easily with minimum steps.
Minimum
Minimum
steps.
steps. Okay.
Hmm.
So from the participants I request any queries or any question, please.
Uh, Sir, I have a question.
Yeah.
Yes, sir.
Sir, you mentioned about scipy.integrate and scipy.optimize.
Huh.
Sir, where can I get the details of the function in that modules? Like that, there are many functions. Uh, so, is there any reference or is there a source
Yeah,
book
yeah. I
where I can
think
look for it?
Sourav Babu, please give
So,
the references where our participant may access easily.
hmm.
Because in our 6 technical sessions, there are so many library functions and etc. etc. But if
Hmm.
you give the systematic, then our participants can utilize this and score.
Okay, sir. I have included in this reference the source of this some books or some references as bibliography, sir.
But in this here,
Popular books is the Python Abhijit Korgupta. This easier book, sir. This books is available and very easy books, sir.
Amazon,
Amazon.
Kar Gupta.
Hmm.
Free PDF is available? No.
Yes, sir. Yes, sir. This is available in our college library also.
No, no. I free PDF free in our system. Google. No.
PDF is some portion of PDF is free.
Okay, okay. So not total book is free. Oh,
No, no, sir. I have purchased already purchased
yeah.
it
Oh,
from.
no problem. Uh,
This is very easy book, sir.
any more queries? Any more? Ajay Babu, any question or any queries? Okay. So thank you, Sourav Babu. You have presented nicely. and you have shown how can we use the Python programming to solve the different numerical problems. You have started from the roots to the integrations in son one third and etc. and differential equation, system of differential equation, etc. etc. So thank you again, and on behalf of the organizer, I want to hand over the your certificate. So please wait. Okay.
Okay. Okay. Okay, sir. Thank you, sir.
Yes. Is it visible? Is it visible? If you,
Yes, yes.
yeah, yeah. Thank you, Sourav Babu, for your nice presentation, and you have given the time to our participants. Again, congratulations, and again, thanks. Now, okay, stop recording. So now 5 minutes is break, and after 5 minutes we shall start our